The next question is a 24-mark question, folks. It's an absolutely beautiful question. It's on the screen. It says the following. In the diagram, we have a circle. The circle has a center at M. Okay, so immediately we know those two lines are equal to one another. Why can I say that? Because they run to the circumference of the circle. Any line from the center to the circumference is called a radius. And a radius, no matter where it is on the circumference, the radii are equal to each other. So if we need to work with those lengths, we need to find only one of them. Okay, let's read on. The circle has that center and radii AM and MB, happy, cuts the x-axis at A and B. So fine, that radius cuts there, that radius cuts there. Hopefully, now folks, please, before I read on, you cannot assume that things are if we didn't tell you that they are. By that I mean the following. You cannot assume that PB is a tangent to the circle, nor can you assume that PA is a tangent to the circle. You just can't. Okay, it might look like it is, but it doesn't have to be. It could have been something that looks like this. Okay, we don't know whether there's tangents. So don't go by the eye. Go by what you've read and the geometric relationships that information gives you access to. Okay, so remember I haven't read yet whether they are tangents. So let's see what they say. The rest of the information says, okay, I'm going to read it again. In the diagram below, we have a circle with center M, radius AM and MB, which cuts the x-axis at A and B. We've got that. With A, the point that's closest to the origin. What a letdown. I was hoping we would read it's a tangent. So we can't use that information, even if it looks like it is. Okay, so the first one for 3 marks. Find the equation of this circle. Okay, and it's a question that is for 3 marks. So let's just remove what I've drawn over there. The equation of this circle. Where's my pen? There we go. So for 2.1, 2.1 is for 3 marks, the equation of the circle. Okay, that's an L. So let's see. I've got the center. So it's x minus 5 all squared plus y minus 4 all squared is equal to r squared. Now, for 3 marks, we can't find r. That's very interesting. Let's see if there's information that they didn't give us explicitly, but that we can draw from our diagram. We can't find the coordinates of A. That's impossible. We also can't find the coordinates of B. So it looks like we're stuck with r squared, unless we saw the following. Now I'm going to try and, let me just use the yellow line. Can you see that the circle is touching the y-axis at this point over here? At that point. The circle is touching the y-axis, folks. Now, I would have insisted, if I was a moderator of this paper, that they tell me that the circle is touching the y-axis, because nowhere here in the information did they give that to me. Okay, so they just say find the equation of this circle with the information. The only information they gave us was the midpoint. There's nowhere where they say that it touches the y-axis. Okay, and we need that information because that makes this distance 5 units, which makes that 25. And my equation would be x minus 5 squared plus y minus 4 squared. And there's the equation of my circle. Now, folks, if this ever happens in an exam, this is an exam question that I have in front of me, then be certain that your examiners and your teachers that are marking your papers will have that conversation at the marking center. So don't think that they're going to do you in here. Okay, the circle was given and it was touching the y-axis. Okay, so that was for 3 marks. We needed that, else we couldn't continue with this answer. That is what is so strange about this. Now, determine the coordinates of A and B. Okay, the point here and the point over there is what we need. What happens at those points? Let's ask ourselves. Well, MB cuts a circle and MA cuts a circle. That's one way of looking at it. But do we have those equations? And the answer is no, we don't. But what do we know about A and B? We know it's the X-intercepts of the circle. Okay, so for the X-intercepts, remember y becomes naught. So if I make y naught here, and again, remember what I said, you're not going to square out this bracket here. It's unnecessary. Plus, if y is naught, there's a 16, and that is equal then to the radius squared, which is indeed 25. Okay, if I throw the 16 over, becomes minus 16, which leaves me with a 9 on this side. And on the left-hand side, I have x minus 5 squared. I take the square root both sides, and I have plus or minus 3. Now, all that's left is to take the 5 over. So it's positive 5 plus or minus 3. The one that's closest to the origin is XA. So the x coordinate of point, can you see how nice I'm splitting this now? 5 minus 3 is 2. And the x coordinate for point B, the one that's further away from the origin, is 5 plus 3, which is indeed 8. Okay, now they ask you for coordinate pairs. Determine the coordinates of A and B. That's not coordinates. That's just the x values. The coordinates includes the y values. So immediately you go and you say, okay, point A is the point 2 and 0, and point B is the point 8 and 0. Now let's go straight to our diagram and let's put them in there. That is 2 and that is 8. Yeah. Okay, let's continue to the next question. That was for 4 marks, by the way. Nothing to sniff at. So far, you've got 7 marks done on this question paper. Okay, now remember what I said. It did not tell us that the circle was tangent. It had to give us that information, folks, else there was just no ways that we could continue with this question. So if this was an exam paper question, which it looks like it was, then the moderator would have picked that up and it would have been fixed before it went to print. Okay, so let's go for 2.3. Okay, let me move in a little bit there. 2.3, there we go. Okay, 2.3 says the following. Determine the equation. Now they say something. Determine the equations of the tangents to the circle from a point P to points A and B. Okay? Determine the equation of the tangents from point P to point A and B, which lies on the circle. And this is what it brings in for us. It makes that angle a right angle and this a right angle, folks. So we have, we've got 2 tangents and they want the equations of those tangents. Okay, what do we have about the tangents? We have a shared point. The shared point here is at P. We don't know what the point P, the coordinates for point P, but we do know the coordinates for M. Let me just go up here. For M over here, and we have these coordinates. Because they're perpendicular, we just need this gradient, and we can use this coordinate pair, or let's just see, from there to there, to find the gradient. And we use this coordinate then to find that equation, and the other one to find the next equation. So there's quite a few ways we can do that. I'm going to take that approach. Okay, so the gradient, The question is for 6 marks, so it is quite a lot of work. The gradient for MB is the following. Now remember, this is 8, 0. So it's 0 minus 4, which is minus 4. 8 minus 5, which is 3. The gradient for MA, let's just find that gradient as well. That's this gradient over here. This is the point 2 and 0. So 4 minus 0 is 4. And 5 minus 2 is 3. Then we also have that this passes through point B, which is the point 8, 0. And this one passed through point A, which is 2, 0. Okay, so I'm ready to find the equations of those tangents. So the tangent at B is the first one I'm going to find. The gradient of that tangent is going to be 3 over 4, because at the point of tangency, the two of them are indeed perpendicular to one another. Okay, and we're going to use that, the fact that they're perpendicular, to find gradients with. Okay, so now I've got the gradient and I have a point that lies on the line. Then I can say the equation of that tangent is y minus 0 over x minus 8 is equal to 3 over 4. I'm going to continue with this on this side. Let me just make space for us. If I cross multiply, I get 4y equals 3x minus 24. I divide by 4, y will be 3 over 4x minus 6. So that's the tangent at point B. A full 3 marks for the work that I've done so far. Remember, there's 2 tangents I want, so I need to find the one at A as well in exactly the same way. So let's go. The tangent at point A. For the tangent at point A, I'm working with this gradient. The gradient of that tangent will be minus 3 over 4, and it goes through point A. So finally, I can go and I can say x, or y minus 0 rather, over x minus 2 is equal to the gradient, minus 3 over 4. I cross multiply, I'm going to take the negative with the 4. So I'm getting minus 4y, which is equal to 3x minus 6. The minus 4y, or the y, then let me take the y, the minus 4 over, is minus 3 over 4x plus 6 divided, the minus 6 divided by minus 4 is positive 3 over 2. Let's just see that we did everything correct there. We took that over, yeah. Okay, folks, so that gives us our second tangent. The tangent at B and the tangent at A. Remember, they are perpendicular to the radius. That's the information that we used. All of this was for 6 marks. There might be shorter ways to do the same question, but yeah, you get the same answer at the end of the day. Let's look at the next one. Oh, I expected this. For 5 marks, the coordinates of P. Now, P is the point where the first tangent and the second tangent cross one another. Okay, so we know. What do? We have to use our 2 tangents because they intersect at point P. We're going to make them equal to each other because they intersect in that one point. And what's beautiful already, I have, if you look carefully, I have y isolated already. So all I need to say is that this side must equal that side to find the x value for this. So this is section, 2.4 of this question. Section 2.4 then says, 2.4, that minus 3 over 4x plus 3 over 2 has got to equal 3 over 4x minus 6, because at that point those two things are equal to one another. Now there's 2 things that bother me here. I have got a LCD, I need an LCD for 2 and for 4, which is 4. Okay, and I'm going to multiply both sides with 4. I'm not going to try and work with fractions here. It's the easy way out. If you have an equation and there's fractions in that equation, get rid of them because you're bound to make a silly mistake. Okay, if I times both sides now by 4, because the LCD is 4, I get minus 3x plus 6, which is equal to 3x times this by 4 minus 24. The 3x comes to the left, so I have minus 6x, and the minus 6 goes to the right. I've got minus 30, and if I divide those two by one another, I get my x value for point P. Let's put the little p down there, is 5. How do I find the y value? I go back to one of the equations. Try the one with the least negatives or the least fractions in it, so you don't stumble over the fractions. So here, for the y value of p, I'm going to use the top one. I'm going to say it's 3 over 4. X just became 5 minus 6. So that gives me 15 over 4 minus the 6 here. I'm going to write as 24 divided by 4 because that is what 6 is. Okay, and then 24, the 15 minus 24 leaves me with minus 9 over 4 for my y value of point P. Okay, a little bit of work. The second part of that calculation wasn't that nice, but also not that difficult. It's basic fractions, so there we couldn't avoid the fraction. We could have by multiplying with 4 first and divide the 4 back at the end of the day. So my point P is the 0.5 and minus 9 over 4. Okay, let's see what the last part of the question says. Wow, this question is loaded with marks, folks. The last part is saying to us, calculate the size of angle AMB. Now let's go to the diagram. The size of angle AMB is that angle over there. So let's call that angle theta. Okay, I want the size of angle theta. Oh, yeah, this is beautiful. This is beautiful. Look at this. We've got an isosceles triangle. And in the isosceles triangle, we now know that this angle over there, maybe I must use yellow because it doesn't show that nicely. This angle is equal to that angle. Now, if I can find one of those two angles, then I have to say that theta will be 180 minus twice that angle, the sum of the angles in a triangle. It is the question, okay, it's got 6 marks as well. So there's quite a bit of work to do over here. How can I find this angle? Well, first of all, I am going to find that angle. Let's call that angle alpha. Why am I looking at that one? Because 180 minus that gives me access to those two angles on the inside that are equal to one another. Now remember what we said. To get to your inclination, you're going to take the second function tan of the gradient. And because the line has a negative gradient, it's going to give you this angle here. If I produce that line, the result is going to be this angle over there. If you add 180 to it, you have angle alpha. Okay, so we need the gradient of BM, and we just found that gradient of BM. Where is my gradient of BM? There we go. Minus 4 over 3. So for 2.5, the gradient of BM, we said, is minus, now can you believe I forgot it? Minus 4 over 3. Okay, so why is that important? Because it is this line over here that I'm working with. I want that so I can get access over here. Okay, so first of all, I'm going to find the angle. The angle then, let's just call it theta, will be the inverse tan of minus 4 over 3. Okay, now if I go to my calculator, the inverse, let's clear that. The inverse tan where's tan there, of negative 4 divided by 3, I close my bracket, I get minus 0.023. If I add 180 to that, so that looks like it's very, very close to horizontal, minus 4 divided by 3. We've got the right one. Okay, so if I add 180 to that, I get 179.98. Okay, so that angle there is 179.98, and I'm deliberately not going to 180 because it is going to be impossible for that angle in the inside to be 180. Then I'm working with this as a triangle. Which, yeah, let's have a look. Now I've got that ugly angle over there. If I now go and I subtract the little 180 from that, it gives me my dot. So let's just call that dot alpha for now. Alpha will be 0.02 degrees. This one on the inside. So if there's 2 of them, then I double this up and I get 0.04 degrees. Okay, and then what now? 180 degrees minus the 0.04 degrees gives me the angle that I'm looking for, which is this angle over here. Okay, so let's have a look. MB was minus 4/3. Perfect. Okay, so if I take 180 and I subtract that from it, I get a result of 179.96 as that angle that lies at the center. Now, folks, let's just go back to the diagram and let's talk about the method over here. I have a suspicion that we made an arithmetic error somewhere. We wanted this angle over there, the theta. I saw that, okay, for me to find the angle AMB, which is that angle AMB, I have an isosceles triangle, so I'm going to try and find those. How did I find them? I used that gradient of the line segment MB to calculate the inclination of the line. That inclination, once we had that inclination of the line segment, we then found the size of, if we could have just worked with vertically opposite over there. Okay, so one way or the other, we found this one. We doubled it up because there's 2 of them in that little triangle. We took 180, we subtracted those 2 values, and we got the answer for the actual angle that they asked us to find.